Hi, hello, good morning, everyone. This is SHRAVANI, working as assistant professor in EC department. Today, I'm going to discuss about switching networks in switching techniques in computer network. Uh, Basically, a switch is a device, and switching is a process of transferring the data packets from one node to the another node, or from one node to the another network, or else from one network to the another network. So basically, a computer user who experiences this all type of switching techniques all the time, like accessing the internet from a computer device. So whenever a user requests any web page to be open, so the request is processed through switching of a data packets only. So a switch is a device takes place to transfer a data from one node to the another node. So it is capable of creating some temporary connections between two or more devices linked to the switches. So switching takes place in data link layer. So as I've already discussed that in the physical layer, the data has been converted into frames or data packets from the electrical signal. So after the completion of conversion of data packets from the electrical signal, the next process of the data communication is switching technique. So this switching technique is a process after conversion of the electrical signal to the data packets, then to transfer the data from one node to the other. So in this lecture, we are going to discuss about different processes which involved in the switching and what kind of hardware is used in the switching. So here you can see a switched network which has dedicated piece of the computer hardware which facilitates the process of switching. So here the data packets will be uh, taken, uh, retrieved. So here data packets will be retrieved from the port which is connected to it, that is A to the first switch. Then the switch, after getting a data packets to it, from the source computer, it has to send to the destination computer, uh, and it has to decide from which port it has to be passed. So to pass this port, it has some switching table so that the destination address, that is MAC address, will be saved in the switching table. So uh, already what is an like a hub and a repeater? We have a separate devices which can be used like switch also, hub and repeater. So but in the hub and repeater, we don't have any lookup tables or switching tables which will save the address of the destination and a port number. So here in these switched networks, we have different types of tables which will be saved the address of all the ports which are connected in the network. Here we have 5 switches which are connected to all the devices around it. So if, for example, the device that is A wants to send data to the F, then the switch 1 will retrieve the data from the source computer, that is A, and sends the data to the switch 2, then 3, then 4, and the F. So before sending a data to the next port, it will check whether the destination address has been saved in the table or not. So that address is known as MAC address, media access control address. So, uh, so we have divided, so we got a different types of switched networks. In that, first one is circuit switched network, and second one is packet switched network, and the third one is message switched network. So in circuit switched network, this is a network which consists of number of switches which are connected in a physical link. So here connection between two stations is a dedicated path made of one or more links. So what happens in circuit switching means here, if their data has been sent to from A to uh, destination B, so before sending any data, any type of data, the path has to be established. So that path is called setup phase. So before sending any data, we need to establish a path from source to destination, so that after sending a request to the destination, then destination will send an acknowledgement to the source. Then after getting an acknowledgement, the source will send the data. So here, each and every link from source to destination or from switch to switch, we have different channels, n number of channels. Similarly, like frequency division multiplexing and time division multiplexing. So here link is divided into n number of channels using the different multiplexing techniques. Coming to the next slide, here three phases are needed to communicate two parties or multiple parties in a conference call. So if we have a one source and want to send the data to two or three devices, then also we can use this circuit switch network. So these are the three steps to be followed for the circuit switch networks. First one is connection setup. So what is connection setup? This means, just now I have already discussed that, that means creating a dedicated channels between switches. So between a link or between our devices or between a switches, we need to create one dedicated channel, that is dedicated path between the source and the destination. So after creating a path, the data has to be transferred. So that comes to the second step, that is data transfer phase. So after the establishment of dedicated channels, dedicated circuit, the two parties will transfer the data. So after completion of data, then one of the device, either source or destination, will need to disconnect the connection. So to disconnect the connection, a signal will be sent to the switch from destination or source to release the sources, to release all the resources. So one thing here we need to remember that whenever a channel or dedicated path has been established, the resources which are passing through the path which is passing through the particular resources, that will be reserved for that communication. So other devices or other ports or other switches may not use this switch until unless it has completed the communication end. So till the end of the transferring the data, all the resources should be reserved for the particular communication only. So this is one drawback of a circuit switched network. So here you can see an example of trivial circuit switched network. So here we have 4 switches, and switches name has been indicated here 1, 2, 3, 4. So for each and every switch has been connected to the other switch with one link and n channels. So to divide a link with n channels, we can use here frequency division multiplexing or time division multiplexing. So for example here, to one of the port, so for each switch we have 3 ports here. To one of the port, that is A, source computer wants to send data to the port of a third switch, that is M. So M is a destination, A is the source. So the A will send a request to the switch, then switch will accept the data packet and such that, and it will find the address of destination in the switching table. So if the MAC address of destination and if the MAC address of destination and the address which is there in the switching table will match, then the setup phase will be connected. Then the link will be, the path will be established. So after establishment of path, then the data will be transferred from A to switch 4 and from switch 4 to the switch 3. So if in case, in the second case, like if the MAC address is not matched with the switching table, then it finds the other port. It finds the other port whether the MAC address is matched with the switch 2 or switch 4. So here there is only the other option, that is switch 2. So if this is not matched with this address, the next port we can check from the passing through the switch 2. So after completion of data, the source computer will send a request or send a signal that the data has been completed, then connection can release. So all the resources which are working here, the switches all working here, the ports are working here, will be released from the resources, released from the transmission. So like this, the switched network has been introduced. In this, each and every link are in physical way. So the links are in physical, so there is no wireless connection in this. So coming to an example, this is an example of a circuit switched network that A sends a setup request that includes the address of system M. So switch 1 will find a channel between itself and the switch 4. So just now I explained you, first it finds the channel to reach the 4, then after it reaches the 3. So an acknowledgement from system M needs to be sent in opposite direction to the system A. So once the path has been established, it has to send an acknowledgement to the source computer, that is A. So then only the A will start sending the data after getting an acknowledgement from the system M. So this takes place in physical layer. So this is the first type of switching technique in the switch network. So this is a basic technique which is used in the starting time. That is the data transferred between two stations are not packetized. So here the original data will be sent. That is continuous flow of data will be sent from source station and received by the destination station. So we are not sending any address in the data. Only we are sending an address, destination address in the setup phase. So whenever the link is established, at that time only we are sending an address to the destination address in the setup phase. So coming to the efficiency, circuit switched networks are not so efficient because some resources will be allocated. They are reserved for entire process of communication, so that the time taken by the resources will be wasted, and these resources will not be available for the other communication, other part of connections. So here delay will be more and the usage of switches will be more, and here data is not packetized. So the efficiency will be reduced. The efficiency is not up to the mark in the circuit switched network. So here you can observe a delay whenever the setup phase has been established. The connecting setup phase connect from A to B and acknowledgement from B to A. We have some delay here, and this part is called data transfer. Complete data has been transferred. So after the completion of data, we'll get the signal that disconnection setup. So here delay will be in terms of connection phase, data transfer, and tear phase, that is disconnection. So here we have completed the circuit switched networks. So coming to the next part, that is packet switched network. So here messages need to be divided into packets. So what happened here in circuit switch we have done, the signal will be sent continuously through only one way, only one path, only one route from source to destination. But coming to packet switched network, size of packet is determined. So the messages will be divided into some packets, 1 to 10 like that. So the size of packet will be determined by the particular network where they are using. And here all the resources are free. There is no reservation, there is no allocation before the data has been sent. So before transmitting a data, the resources are not reserved. So they are free from the allocation. So allocation will done first come, first service. So whenever a packet Whenever a switch receives a packet, then only it will reserve that switch. So whenever a switch receives a packet, the packet must be wait if there are other packets being processed. So for example, if a switch is doing the other transmission, if the other system like B, A is also, this switch is doing the work like transmitting the packet coming from the B, but again after some time, if the switch gets the packet from A also, the packet has to be in a wait position until unless the other packets has been processed. So here, lack of reservation may create some delay. So in circuit switching, we have done the reservation so that switches will not do any other work. Only the work given dedicated work it will do. But here, reservation is not done. So this may create some delay in the packet switching. So in the packet switching, we have two types, that is datagram networks and virtual circuit networks. So what is datagram network? So here, datagrams means here the packet is known as datagrams here, which is treated independently of all others. So each message is divided into some datagrams. So you can observe here all the packets are belongs to same message. So these data frames are transferred to their destinations according to the available resources. So available switches by seeing whether the switches are free or not. If there is free, then packet will be moving to the next switch. So it will check before transferring the data. So if the resource is free, if the switch is free, then it will move. If the switch is not free, then it will move to the other route. It will search for the other route to reach the destination. So this type of technique is used in modern computers in the internet. So datagrams, which is done in network layer, and this approach can cause the datagrams, that is packets of transmission, to arrive the destination out of order. So for example, if one has been reached, if the next packet is 4, next packet is 3, and next packet is 2, the packets are not in an order. So this is a problem in datagram network. So for each and every packet, the source has to be sent the sequence number so that the receiver, the destination computer responsibility is to arrange the packets in order. So you can see here, packets may also lost or dropped because of lack of resources or any delay. So in this type of problem, in this type of datagram network, the responsibility of an upper layer protocol to reorder the datagrams or ask for lost datagrams. So if there is any lost due to the switch problem, then the receiver or upper layer protocol responsibility is to ask for resend again the same datagram or reorder the datagram before passing them to the application level. Yes, got my point. So in most protocols, the responsibility of the upper layer is to reorder the datagram in the destination time and destination place, and or ask for lost datagrams. So this networks are referred to as connectionless networks. So in this datagram switching, there is no connection before sending a data and after sending a data, and there is no setup phase and tear down phase. Then how the packets will be reached to the destinations. So just in the starting slide, I have explained that for each switch, we have some table. So that table is here, that is known as switching table. So here, each packet switch has a routing table. So which is based on destination address. So for example, here we have 4 ports. So from port 1, we have destination address of 1232. And for port 2, we have destination of 4150 is destination address. And output port for 3 is 9130. And for 4 is also some other destination number. So the routing tables are here dynamic and will be updated periodically. So periodically will be updated for each and every type of connection. So the destination address and output ports will be recorded in each and each switch. So for each and every switch, we have the switching tables in the net. So the destination address will be the header of the packet. So for each and every packet, for each and every datagram, we need to maintain a destination address so that we can identify from which port it has to be passed, it has to forward. So if this packet is not matched with this port, then it has to go for the other port. So when the switch receives a packet, this destination address will be checked, verified. Then the routing table will be consulted to find out the destination, corresponding port to reach the destination. So this is how the packets will be reached the destination by using the switching table. So coming to efficiency in the datagram network, it is better than circuit switched network. So here, why it is better than circuit switched network means, here the resources are allocated only when the packets are transferred. So whenever a packet is ready to send, then only the resources will be allocated. Before itself, we are not doing any reservation process in the datagram switching. So if the source sends a packet, there is a delay few minutes before another packet can be sent. So if the switch is already busy, then it has to wait for the some minutes. Then the resources will be allocated to the our switch. So due to this, some amount of delay will be erased, but this is better than the circuit switched network. The delay will be less than the circuit switched network, and efficiency will be more. So this type of datagram approach will be used in internet in the network layer. So coming to the next slide, here delay in a datagram network. So here we can observe there is no setup phase, there is no connection phase and connection tier phase, tier down phase. So the only waiting time is transmission time and waiting time until unless a switch has been freed from the other relieved from the other work. Then again here also we have some waiting time until unless switch is released from the other transmission. Then here we can call it as 3 transmission times and 3 propagation delays and 2 waiting times. So this is completely complete delay of datagram network, which is less than the circuit switching. So this is the second part of virtual circuit network. It's a, this is a combination of 2 networks which we have seen till now, that is circuit switched network and datagram network. So, and it has some characteristics of both. So circuit switch network, like we have created some path before sending a data, and a datagram network, we have some tables which are taken, which has reserved like lookup tables or switching tables, which will be saved the saving the destination address and the ports. So some of the characteristics have been taken from the circuit switching, and some of the characteristics have been taken from the datagram network. Coming to here, characteristics, the packets from one end system to another end system will pass through only same path. So like circuit switching, it will pass through only one single path along the same path. So this is same like circuit switch network. So this characteristic is same like circuit switch network. So here also we have 3 phases, that is setup phase, data transfer, and tier down phase. Here setup phase, resources will be allocated during the setup phase only. So the first part of communication is same as circuit switched network. So here packets are, here the data will be packetized, means the message is divided into some packets. So this part is like datagram network, and each packet will carry a header. So for each and every packet, there will be a header, and this network is implemented in data link layer, whereas datagram network is implemented in network layer, and this network is implemented in data link layer. So we have for each and every packet, we have some address, that is address in the header. So here we have two type of addresses, that is global addressing and local addressing. Uh, what is global addressing? So global addressing is nothing but using a unique address during a setup phase. So whenever a source and destination needs some address, which is used by switches. So switches need to know where it has to go, to which port it has to reach, to which destination it has to go. So we have to maintain a unique address which is not same with the other switches. So here we have some source and destination needs some unique address. So that is called a global address here. So coming to the setup, local addressing, this is completely uh, temporary way. So here this address is known as virtual circuit identifier. Virtual circuit identifier. So actually what happens here, the data with the data, we are maintaining some address. So with the data, we have some address here, that is 14 and 77. So this indicates the VCI address, that is uh, virtual circuit address. So to which port is getting from for a switch here, the port 1 is receiving the data and the VCI address. So VCI 1 14, VCI 1 77. So this 14 and 77 are known as virtual circuit identifier. So this is used for data transfer. So whenever you are sending a data, you need to send the packet with this virtual circuit identifier. So to identify the next port, to identify the next switch, we need to have this virtual circuit identifier. So this is called a small address used by a frame, nothing but packet between two switches. So between two switches, we have this address which is varied according to the data transfer. So this is the setup request. In setup request, we have some uh, global address here. So you can see here an example. In setup phase, we access packet switch. So here all the switches, we have three switches here and two sources. Source is A, destination is B, and here for each and every switch we have some table, that is port 1 is incoming switch 1 and port 3 is outgoing, and with VCI is 14, but the VCI of 3 has been not known in the setup request. So before sending a data, we will create a path. So in that path, we are sending some request to the destination. So in this request, it doesn't know the VCI of particular switch. So it doesn't know the VCI of particular switch. So we'll send blindly to the switch, so that we send blindly to the switch. So the switch 2 will accept this and sends to the next switch to reach the destination. So if the destination B accepts the request, then it will send the VCI, that is virtual circuit identifier number, in the acknowledgement. So here you can see the switch in the setup phase acts as packet switch, and it has a routing table used to know the output port number. So we need to know the output port number and VCI of the receiver. So after setup request has been sent from source to destination, then the destination B receives the frame. So it will receive the frame, and if it is ready to receive the data from A, it assigns a VCI. Then the responsibility of this source, receiver, is to assign the VCI, that is 77, and this VCI will let the destination know that the frames come from the A. Frames comes from the A. So here 77 is received, and here 22, and here 66. Now, after setup acknowledgement has been received from the B to A, then data transfer has been done. So here, after knowing this, here we have not sent any data. We have just knowing the output port and VCI. in this acknowledgement and setup request. Coming to data transfer, then the A will send data with the frame VCI number, and the 3 also sends the data with the VCI number. Here, data will not change, but the VCI will change, updated accordingly where it is moving, where it is forwarding from one switch to the another switch. So after sending all the frames, a special frame is sent to end the connection. So after sending completed all the frames, then it will send some special frame to end of this communication. So destination B will respond with the tear down confirmation frame. So it will give an acknowledgement to the A that connection will be released. So this is the process of virtual circuit networking. So here in this we have first part connection phase, and disconnection phase is completely similar to circuit switch network. Coming to the packets and address and switching tables, all this process has been taken from the datagram network. So here delay. So in datagram network, what happened? Each packet experiences a wait at switch before it forwarded. So before it forwarded, each packet is in waiting stage to allocation of the resource by the switch. So here delay is not constant. So it may be more, it may be less, depends upon the switch schedule. So in this virtual circuit, there is one time delay for setup, because before only we have setting the link from connecting the link or creating a link between A and B. So there will be some time delay for setup and one time delay for TR. So if the resources are allocated during the setup, there is no wait time for individual packets. So there is no wait time when transmission has happened. Only total delays, setup delay and tear down delay, and 3 transmission time delays and 3 transmission time delay and propagation delay. So this is about virtual circuit network. So coming to the last one, that is message switched network. This is an older switching technique that has been not used now. So in this, the entire data will be forwarded with the entire network. So there is no efficient in this. There is no process has been included in the message switching. So thank you all. By this, we have in this lecture we have completed the 3 types of switching, that is message switching network, circuit switched network, and packet switched network.